Alright, so in this video we're going to go over Apache Zookeeper. We're actually going to go over a distributed app. In this case we're going to use 3 servers. We're actually also going to bring this down into a Kubernetes level, so these will be running on pods. Why use Apache Zookeeper? So with distribution you're going to run into a number of issues, specifically race conditions. Apache Zookeeper has been tested throughout the open source industry, so it's hardened. Anyways, we'll actually go over the installation and then a quick test to show you how this works. Alright, we're going to go over a couple things in theory real quick. Let's go ahead and go over what's needed. Okay, so first off we're going to draw out, let's say 3 servers. Actually, let me clean this up just a bit. We need more space. 1, 2, 3. Our label is 1, 2, 3. So basically what it is, the backend is a Java jar file, so it acts as a database. So what will happen is on the back end we're going to have 2 different ports. We need, actually let's start here, 2, 8, 8, 8. And these guys will communicate on that port to elect a leader, as well as transfer data between each other so that everything's in sync. To elect a leader, so let's say the leader's lost or we lose a node, they need to communicate on another port. So that's 3, 8, 8, 8. So that's what's going on in the back end. So when data is written to one database, they all stay in sync, and they all sync together through 28888. Like I said, 3888 is going to be used for electing leader. Now on the front end, we're going to use port 2181. And so basically you're going to have a bunch of different clients, right? And they're going to connect to one of these, or multiple, right? And so everything will stay in sync. This guy will be leader. Let's say he's elected, and they will synchronously connect, or at least transfer data over to leader. But anyways, all the databases will stay in sync and be able to continue. Okay, cool. Now let's get over into, actually I'll show you the website real quick. You can get all this information here. The important part is when we look at the configuration file, you need this to say server. I screwed up and decided naming this differently and could not get things to work. Turns out this is default. You need this to say server. Then this will be either your host name or your IP address, or for the node that's currently configured, it's going to be 0.0.0 because we want it to bind to everything. Okay, so let's get over to the YAML file. I'm actually going to drag this file over here and open this up. So if you're new to Kubernetes, don't let this confuse you. We're going to start basics, or at least keep this as simple as possible. Anyways, namespace. We're going to use the Zookeeper distributed namespace. You will need your secret set up so that way you can pull Docker images from your registry. Obviously I'm not going to put my base64 password here, but basically it is the docker config into base64 format, dumped there, and then as your service, again, these same ports, 2181 for the client, distribution will be 2888, and then elect will be 3888. So I'm going to have 3 of these. Reason being is when you have pods communicating to each other, they're not going to communicate via server to server. It's going to be their service to service, and the service routes to the host. Confusing, maybe a bit, but just stick with me, we'll get to it. The next part is we need the configuration file, and the configuration file from Zookeeper, you can download it and look at it. It's a bit more word salad. However, we just need the basic shit, right? So if you want to learn a little bit more about these and understand why you need like a 10-second init or sync limit, please pay attention to this. Sorry, please pay attention to this. For most part, defaults are fine though. The data directory we're going to use is varlib Zookeeper, and the reason why we're doing this is because the hosts themselves, the actual Kubernetes nodes, they have a backend data directory that's hosted on an NFS share. The reason why I did that is because I want to save my data. Let's say I have a I don't know, shut off my VMs, cool, whatever. We need to make sure that the data is going to exist or persist. So for right now, all you care about in the Kubernetes pod or container, this is where data is being written. And then of course we have our client ports. And then as I mentioned, this is the first server. So we're going to set it to all zeros for the IP address, right? And then the host name is actually going to be for these first 2 and 3 servers. We're going to use their service. If you run a DNS lookup within Kubernetes, you will actually find the IP address. And we'll get to that. We'll show that in the Kubernetes config. And again, 2888.3888. Cool. And we're going to have 3 of these configs because we have 1, 2, and 3 servers, and they're all going to have their own individual function. You can create a MyID file, but I actually just built those into the NFS shares because that's where the data is saved anyways. So this is important. You must have this. What that looks like, actually, just so you can see real quick. Kubernetes Zookeeper. Well, what it looks like back here is this. We'll do server 1, and you can see the MyID file right there. If we cat that, we can see 1. Now if I cat all 3 of them, you will see 1, 2, and 3. Okay. Moving forward, persistent volume for each one. Server 1, PV, sorry, we have a persistent volume and then the claim, right? You'll need both of these so we can mount them to the deployment. And in this case, we have the application distribute app1. And this is what we'll need 3 of these deployments. Each one's labeled 1, 2, and 3. I'll actually just share this config online because I figure it makes your life easier. And then we have the registry where the image will live. Okay, so container ports, the volume mounts, and then the volume. They obviously route CFG map up. Actually, we'll just do this real quick. We scroll up here, we should see CFG map, and then we're going to use the file from CFG. Let's go down here, and you can see it right there. Anyways, the mounted path on the pod will be this because we need to be able to read the configuration. Again, the mount path for the first volume will be varlib zookeeper, and that's where the data is being written. And that's pretty much the same thing for the first 3 apps. Same thing. And then as we get down to the client, because you want to create clients. We'll start with 1 client, but I'm going to dump this up to, I think these Kubernetes servers can handle up to like 160. We'll only bump it up to like maybe 50 or 100. Just so we don't like crash the hosts. Okay, cool. So yeah, it will have its own image. And what that image entails is... Okay, my bad. Just realized half my terminal was not showing. But yeah, back to our Alpine image, you will see that we have just a basic Alpine image with Python, and then we have a test script. I will post a link to that script. It is not mine, I just found it online. But I figured it was a good way of testing just a simple lock on the servers. And we can actually see that running. We will get over there, test that out. So next up, I'm going to show you how to deploy these, actually build the images, push them to your registry, and then we will actually deploy them. And from there, we'll just start with 1 client, and then I'll show you how this can scale up and you can see everything. Okay, so first off, we need to get the Git repo. CD over into development, Git Zookeeper, and if you're curious where that repo is, it is in the config. So yeah, just this guy right here. I will include a link to that as well. Okay, cool. So we're just going to go into 3.5.9, and some of these files shouldn't exist. I was using them for testing. So if I cat myid or cat zoo cfg, yeah, these don't have to be here because you're going to be mounting them through Kubernetes. I did leave these here though because Docker. If you're not using Kubernetes and you want to include your own configuration file within Docker, you could just build these by copying these files into the Docker file and updating 1, 2, 3, and then updating your config. So 1, 2, 3. Obviously, this 0, 0, 0 will move around, as well as these domain names will change to something more like .com, .net, or you can just use IPs. For Docker, I personally would just use it for testing, unless you're going to do like Docker Swarm. Okay, cool. So let's take a look at our Docker images, see if we need to get rid of some of these. Okay, so we just have these. Okay. Let's build this guy. We'll label, actually, I just leave this as is. Cool. Well, as you can see, most of these are cached and built just fine. So at that point, now that we got that, we can go ahead and push it. Yeah. Okay. And then as far as the client, we're going to move over to internal and Zookeeper. Cat Alpine, again, same image, right? We're going to build it. Client 5. I mean, it's already there, so most of it's cached. But then we'll push it. Cool. Now it exists. Okay, again, we have that full deployment YAML. And if we look at our pods, we've got a bunch of stuff here. We have Calico for obviously networking. We have our core DNS, right? The major ones that might help you out is the load balancer. I probably should update my previous video on our container toolkit because Traffic 2.0 has has been updated, and it's changed a lot since the previous deployments. In this case, we don't really care about an ingress controller because we want this to stay within the cluster. We don't want anything inbound at this time. Maybe we might open that up down the road, but for now, we're going to have all of our clients as pods so they can stay within the Kubernetes networking. So let's go ahead and update this. Let's go ahead and apply it. Okay, and then let's go ahead and check our pods. And of course, we can check our logging. The major thing you want to watch out for here with logging is you want to make sure they don't enter standalone mode. If they enter a standalone mode, that means configuration file screwed up or your MyID did not stick. Why that would be is probably because Kubernetes, well, in my case, the NFS share wasn't mounted, or we might have the file in the wrong directory. So let's go ahead and check this one more time. Hey, that was fast, it's all running. So let's check the logs. And as you can see, actually, let's scroll up here real quick. Okay, so usually right about here, you'll see standalone mode, and if you did, something's wrong. At that point, you can exec into the pod using bash because they do have a bash environment. But anyways, you can see that everything's kind of like trying to create quorum, right? By the way, this is not secure. There is no TLS communication between the servers, so be aware of that. Maybe I might cover that down the road, but right now this is kind of just to get you in the flow of getting Zookeeper up and running. Okay, so eventually we will see it's following. So it was able to make communication, and right now this pod is following. So JCMM, so app1 is the follower. Let's check app2. This one is the, hey, we got a leader. So this one's our leader. So let me check, oh sorry, get pods. Okay, let's check our client. We should see an update every 1 second. Okay. Okay, I was definitely screwing up my namespace. Okay, cool. So let's check the logs here. And there you can see we have every second. 9, okay, cool. So anyways, yeah, you can see this has been running for, what, like 30, oh, a few minutes. Okay, cool. So let's go ahead and delete this. Okay. Okay, I paused the recording just because it was taking so long, but here we go. Okay. So right now we have replicas 1. Let's bump this up to like 100. Okay, and let's get our pods. So again, these will be creating. I did set these to always pull because currently I'm in development, and even in like production, I might even do that just because I want the latest. If these didn't change often, maybe I wouldn't, but that's beside the point right now. Okay, cool. So you can see we have a number of them here. Let's keep going. Okay, so we have one app running. The other two are still going. You can see all of these creating. Actually, let's take a look at Grafana. Uh-oh. Okay, there we go. So, new password. I'll just throw something in there. Cool. Alright, let's take a look at the dashboard. Browse. I want that one. Let's take a look at a few of these. So the main killer here for this application is memory. Yeah, you can see it's just spiking. That does not look right. Okay. Alright, let's go ahead and check these out. But anyways, as you can see, this works out great. And again, this is just a test. Basically anything you want to distribute, like, I don't know, maybe a botnet or something like that, this is a good direction. If you have any questions, feel free to reach out. I'll probably get a posted update of the new Traffic 2.0, get people ready for that. But yeah, as far as, I guess what we could do is show a quick test of what happens when we lose a node. Let me get that set up. Okay, we're back. So I'm just going to give a quick overview of what we're looking at. I know it's not the best, but I will try and separate the best I can. So first off, these 6 terminals up here are going to be our clients, and their job is to reach out to the Apache Zookeeper instances and obtain a lock for 1 second. Then these 3 bottom terminals are going to be our 3 nodes. I've kind of bloated them so you can see them. Basically what you're going to see is the difference when we actually lose one and how they reconfigure themselves. Something to keep in mind with Zookeeper is if you had 2 nodes and you lose one, the whole thing falls apart. If you have 3, the formula is 2f plus 1. So to equal quorum, you need 2 fully functioning pods or instances, whatever, of Zookeeper, and you have a fault tolerance of 1. So with 3, you have 2 needed, they all stay together, you lose one, you're okay. If you lose the second one, it all falls apart. It scales up as you go, like if you have 5, you can lose 2, things like that. Okay, cool. So let's try and kick these off. These are going to be Docker images. You can see we've routed our ports correctly, and then these are just like my data mounts. Okay, cool. Give that a second to boot, and I'm going to show you one thing in the logs that I think is important. Okay, cool. Again, we don't see standalone. So right now it's failing and throwing a bunch of Java exceptions because there are no peers. Let's get a second one up. This should be enough to get everybody up and running. Hey, there we go. Following leader election. And then let's get our 3rd guy up and running. Using that config, hey, and everybody says, hey, we've got a guy. Cool. Awesome. Quorum. Okay, cool. So let's go ahead and kick these off. I'm going to scroll this down just a bit. So kick this one off, and you can see as I'm doing this, they're going to connect. There will be a delay in some of them, that's okay. But as they kick off, everything's running as expected. Actually, let's bring this down just a bit. Let's try and just kill one client. You can see the logs update saying, oh, this client's having issues. So let's bring it back. Okay. And while that's running, let's kill one of these nodes. It seems like most of everybody connected to this one, so let's kill him. You can see these two are like, oh god, what just happened? Looks like we're still running as expected. Once in a while, you'll get one of these. We had a connection break, but since we're configured to look at all three, I mean, it just moved on over. Now let's bring him back. And yeah. Up to date. All these are fine. All of our clients are running as expected. Now let's just go ahead and let's see. This one looks like a fast leader election, so I assume this is our new leader. Let's kill him. And if you notice, both these guys just updated. So far, our clients are still there. We did experience a transition to connecting, so we're still up and running. Let's get this back up and running. And you can see this is back in. Okay, cool. Let's kill two of these and see what happens. So I'm going to kill this one. And these guys are like, oh god. And we can see some of these disconnected and came right back. I guess not disconnected, they're like, oh god, there's a problem, and was able to rejoin. But now let's kill two. You can see this is freaking out. And all these guys are like, oh god, we lost everything. Now to try and salvage within a time limit, let's bring one back and see what happens. Hey, they're coming back, luckily. We were able to rebuild our pods, or at least 2 of the 3 servers, and save our connections. If they didn't, eventually, depending on how your application is coded, it's going to say, fuck it, I'm done, and just kill itself. Which is probably what you want to avoid data corruption. Maybe we can see what that looks like. I'm not sure if this application is going to save itself. In reality, though, you probably should code your application to kill itself and within a timely fashion, because if you have data corruption in this database, I mean, no snapshots, anything to save you, it's game over. You're done. But I'm not going to go into data recovery and all that. All we can see here is it is effectively dead. Let's see, give it just a few more seconds. So as you can see, I did not code this application all that well. We are still seeing connection refused. Honestly though, it's okay. This is a demo. We're just trying to prove like what happens. Let's see if we can bring it back. Okay, so it does look like we're back. Our clients, yeah, as you can see, expected once. So I'm confident these applications are going to lose themselves. Or at least we lost the session. So these guys, it seems, yeah, session has expired. Yeah, so we've got new sessions, which is good, but hopefully none of these applications would be writing data, because if they did, it'd be like, well, lost what I was looking for. And you as a programmer would want to code that saying, okay, this is where our last byte was, keep going forward after that. But anyways, that's what it looks like in Docker. And then if you want to go the server route, I mean, all you have to do is create like a systemd file. Actually, I think I can show you what that looks like. Let's open this guy up. Systemd, system, zk. Yeah, okay. So this is what my systemd file looks like. If I was running these as servers, but with how cloud is priced and everything, I would recommend running as many pods as possible, save on resources, right? Anyways, if you do go the server route, you You can always have a systemd file, so on startup, this will boot. You will find errors. For instance, for me, it was the varlib zookeeper. I had to go back and update the files to be owned by user and group of, actually, who's my, this user, zoo user. So you'll have to make some updates, make sure files have writing privileges, especially in logs. Var log zookeeper. And then you can just like tail that stuff, right? To test and see what happened. Actually, I'm just going to see what happens here. Yeah, so in this case, I was able to get, I think we were able to get quorum on these. I don't know if I tested that or not. Yeah, we were following. If we find standalone, yeah, so this is the what you'd see if we didn't have a distribution set up between all three. You'd see just, hey, standalone mode, and that was due to my own bad configuration. Anyways, I hope that helps. This information was definitely missing when I was looking for setups for Zookeeper, so this is kind of like a demo of how it works on, I guess, Docker, Kubernetes, and even a server level. If you have any questions, feel free to ask. Thanks.